My name is David Brearley, and the talk today will be on the shear failure of adhesively bonded composite joints in a modified RCAN fixture. And I'd like to thank my sponsors EPSRC and Siemens Healthineers. So the background for my PhD project and the focus is on a magnet found within an MRI machine. This magnet is serially bonded coils of superconducting wire infused with epoxy resin attached to GFRP, spaced out at correct intervals to create the uniform magnetic field needed for the MRI process. These coils apply very large electromagnetic forces when the field is operational, and these forces can exceed 1 meganewtons and are applied on the inner GFRP at cryogenic conditions needed for the superconductive state. Therefore, it's been highlighted that this interface between the GFRP and coil could be the location of failure. And this is the kind of highlight of the work that I'll be presenting. I'm using a modified RCAN fixture, first in shear configurations, and then in the biaxial states that you would expect to find within the MRI magnet. And this is, initially looking at the shear strength. And these specimens are water jet cut out of a big block of material and then milled down to remove any damage left with the water jet cutting, as it's a very difficult material to work with. And then a speckle pattern is applied to enable DIC non-contact measurements. So from the results, here we have the strain components in the transverse and shear directions, and the transverse strain component has a maximum amplitude of about 1/5 of the shear, and this shear distribution is very uniform across the interface. So when we plot the average shear stress in the cross-section of the adhesive bond against the observed shear strain, we find a shear modulus about 2.5 gigapascals and 5.75 megapascals for the shear strength. And I have also looked at the neat epoxy with steel coupons to see if the epoxy by itself acts differently to when it's in these magnet coupons. In conclusion, I get a very nice shear distribution across the interface. Which allows me to measure the shear modulus and shear strength. In the future work, I'll be looking at the different loading hole pairs to examine especially the compressive shear response of the adhesive bond. And this will help generate a failure envelope that can be used in predictive models. And currently, I'm working on doing these tests at cryogenic temperatures. So I have devised a novel cryostat which isolates the specimen from the math rig, and so I can apply cryogenic temperatures just to the specimen. And this is using gaseous nitrogen. And on the left is my initial results, and currently I'm just working on getting the noise of the DIC down so I can use the measurement. Okay, And that's all. Thank you for listening, and I'll take any questions.